Okay, here's a diagram that represents the starting position. Ship B is 130 kilometers east of Ship A. And here's a diagram that shows the situation after a bit of time, 1 hour. We'll let this distance be X and this distance be Y. That means the distance from this point to this point is 130, take away X. And by the way, the rate of change of X is 25 kilometers per hour. The rate of change of Y is 20 kilometers per hour. If I share my screen real quickly and show what's happening, as time increases, focus on the distance from A sub 1 to B sub 1, which is this distance right here. Right now, it appears that that distance is decreasing. But by the time we get to 4, the distance is increasing. So we expect dH dt to be positive when t equals 4. Okay, so here's the relationship between the distance between the ships and these distances right here, Pythagorean theorem. H squared equals 130 minus x, the quantity squared, plus y squared. If we take the derivative of everything with respect to t, we get 2h dh dt equals, here I apply the power rule, reducing the exponent by 1, chain rule, multiplying by the derivative of the inside, times dx dt, plus 2y dy dt. And then notice that every term on both sides is divisible by 2. So if I solve for dH dt, I get, if I distribute this minus 1, x minus 130 dx dt plus y dy dt, all divided by h. And now I can substitute in the values that are true for each of these variables after 4 hours. Okay, so after 4 hours, this x value is 100, which means this leg of the right triangle is 30. After 4 hours, ship B has moved 80 miles north. So h at that point in time is the square root of 30 squared plus 80 squared. So I'll let you work that out, but it looks like this is negative 30 times 25 plus, what, 1600? All divided by the square root of 30 squared plus 80 squared. Okay, and you'll get something, I think it's 9 point something. Okay, but I'll let you finish that up. There you go. Hope that helped. If you have any questions, post a comment.